So what is important is that they're going to describe everything into a context. And with that contextual information, you need to apply everything you know about vectors, which makes the problems difficult. So I go through slowly. The difficult part is you will have to read through a lot of different contexts to understand what they are looking for. First paragraph, nothing much. They just say that they're going to participate in a playground game. But then comes the structure information. As we go through, I'm going to show you where they represent on the diagram. So they say that there's this structure called ABIH, which is a slope. So you will see in the diagram that there is a slope. And there is also this acute angle to the horizontal plane. So there is this theta here to the horizontal plane that contains OABC. Can I talk about the horizontal plane first? What does it mean to be a horizontal plane? Just right below here. Move it up. Horizontal plane. Sometimes the problem calls the horizontal plane as the ground. The flat ground that we have is a horizontal plane. Horizontal planes is usually referring to the XY plane, unless they state otherwise. Because your ground will generally contain the I and J vector. My base plane OABC contains the I and J vector. XY plane, we have done it before. What is the normal vector? The normal is your vector 0, 0, 1. Because this vector is going to be parallel to your z-axis. Therefore, equation for a horizontal plane or the ground should be thought of usually as r dot 0, 0, 1 is 0. Your right-hand side will be a 0 since it contains the origin. Any plane that contains the origin, right side will be 0. Okay, so we continue. They describe the horizontal plane. They say that at the edge HI, which is here, there is a vertical backdrop. So this is that vertical backdrop. Vertical because it is parallel to the K vector. K is your z-axis. So it's vertical. They then carry on. There is this origin given, and there are vectors ijk, which is your usual ijk, pointing in various directions already drawn on the diagram. So there is this ijk, your x, y, and z. Then more things that they talked about. We have got a point x on the slope and another point y on the platform PQRS. Now, where are these 2 points? Let me just highlight. There is this point x on this big slope, and there's another point y on the platform PQRS. So PQRS is like one possible or one segment of the big slope. It's like one rectangle inside the big slope. Then they say in that activity, my student has to walk from point X to point Y. So they're going to walk on that slope. The equation of the plane that contains ABIH is given by this. ABIH is this big rectangle that appears. Let me just rewrite the equation in scalar product form. So that plane that they are giving me now is R dot. Your 3 and 5 will be your normal 3, 0, 5. Equals to 15. This is the equation of your ABIH plane. So this equation is also telling you I know the normal vector. Normal is 3, 0, 5 on this plane. The coordinate of x is alpha 3, 2. Show that alpha is 5 over 3. This alpha value is the unknown of my coordinate x. And x is a point on my plane. So they are trying to ask you to link up the concepts. Let's start with part A. I write it on the left here. So I will say that since x lies on plane, I'm trying to make use of the concept that x is a point on the plane. Any point on the plane, remember, you sub into R, it must give you 15. Okay, so we will take point x, which is your alpha 3, 2, dot with 3, 0, 5 is 15. So we can expand 3 alpha plus 10, 15. And alpha will be your 5 over 3. Then we go to part B. Part B wants you to find the value of theta. Now, where is this theta? Theta is located at this bottom segment. So for you to find angle, you need to relate back to your vectors. Is this an angle between line or angle between planes? You've got to think about which two you want to try to apply. So where is this angle? This angle is actually between two planes. Which two planes is it? Let me just write here. Theta is between the top plane, that slope. That slope is ABIH slope, and the ground, or the base. The base is this OABC. So both of them are actually planes. It's angle between two planes. So you need to then recall what is the formula for angle between two planes. Angle between two planes, we go for cosine. My cosine theta will be, you apply the formula, the top two will be dot product on the normal vectors. Normal vector is 305 and 001. It is an acute angle. Remember, acute angle, you will force the modulus to appear at the top. Denominator, we go for your mod of the two vectors. My first normal was given in the problem. My second normal is using the normal of the xy plane, the ground. So we can do a calculation for theta. In terms of degree, we will get 30.963, which is approximately to 1 dp will be 31.0. Angles will be to 1 decimal place. So next part, again, they give a long description. They are going to say that one end of the iron strut that they install will be at origin. The other end will meet the slanted edge AH at M. So they actually gave you that on the diagram. Origin is here, slanted edge AH is here. That line that they are going to install is this line, such that it is perpendicular. So they say that they will install that iron strut, which is this red color one, that is 90 degree to AH. Can you find the position vector of this point here? So what is it that they are trying to look for? It's the concept of you have a point, you have a line, and you want this 90 degree. So this M is like the foot of perpendicular. Okay, they will not tell you upfront which concept in vectors. That's where you got to relate on your own. So if I go to part C, we're actually trying to find foot of perpendicular from origin to line AH. Remember, foot, you could choose between lines or planes. In this particular, it's line. Or based on the diagram, it is also the same as to plane ABIH. It happens to be the same foot for this 90 degree. So we should visualize the diagram as you have an origin. I redraw into a format that we are more familiar with. This is my plane ABIH. we are trying to find the foot, which they call it as M. This is that 90 degrees. I generally want to turn it into a diagram that we know how to visualize and find the equation for. So the concept for this will always be, we try to find the equation of this line called L, and we try to intersect L with the plane's equation. Let me do it on the left side. Step 1, to solve for this foot, let's recall, I formed the equation of line that passes through O. And parallel to normal of ABIH. So R equals to origin plus lambda direction vector. Step 2 is to intersect L with plane ABIH. When you want to intersect a line and a plane, just to recall again, you take this R from the line and you want to put it into the plane's R equation. You take one R and substitute into the other R to go and find the lambda angle. Okay, so let's proceed. We will take this equation, which is your 3 lambda, 0, 5 lambda, take the R from this line, and let's put it into the plane equation, which is also 3, 0, 5 equals to right-hand side 15. So we expand out the dot product. Once we found the lambda, then this can give me that point OM. We take the lambda, we put back to the line equation. So I have here as 15 over 34 of the 305 vector. So the hard part is they don't describe to you what is the vectors concept. You have to observe on your own that is about intersection to get that foot. There's more parts to the problem. It's the next page. I want to finish all of them. Let me go to the next page. Still the same diagram. Okay, everything I have replicated over here to let you see the values. Okay, so let's continue with what they describe, and that's the hard part, a lot of description. So they say that there's going to be this rotatable spotlight at point T with this particular coordinate. Let me put that onto the diagram. This is that point T that they are mentioned, is at the top here, with coordinate as 0, 5, 10. This is that point that they mentioned. It's going to shine a beam of light on X. That beam of light will follow the student's movement from X to Y in a straight line. Okay, where is that first? Okay, I put in red color. There will be a light shining from point T to line point X. So your light is shining from T to X. It will follow the student and point towards Y as the student moves from X to Y. So you think of it as a light. Usually light is described as a line because it's a straight line from that point T to X, point T to Y. Okay, so that's what they are telling you. When the beam of light is shining on Y, it is parallel to this vector. Basically, they are telling you the direction vector of your line. It's 4 minus 3 minus 9.4. Direction of TY will be 4 minus 3 minus 9.4. So they then say, can we find the acute angle between a slope and the beam of light shining onto Y? So what kind of angle are we looking at? This is angle between plane and line, because the beam of light is treated as a line. This is the angle that will give you your sine. So if I were to start part D, angle between plane and line is that special case. We will have sine theta. Use the normal of the plane, which is the same one, 305, and use direction vector of the line, which is this red direction vector. So on top, we will have 4 minus 3 minus 9.4 dot with 305 over the modulus. I should write in the formula straight away. So modulus will be, we have 4 square, 3 square, 9.4 square. Yes. Okay, to 1 decimal place. Okay. The next one they want is E, but E is simple. So E I will skip, but I tell you what they're looking for first. They want you to find the coordinate of Y. How should we find this coordinate? You have the equation of the plane ABIH. You have the equation of line TY. Because line TY will contain point T, direction you also know. Okay, so this coordinate is simple. You try to treat it as intersection. You want to intersect line TY with plane. It's a simple intersection, so I'm going to skip that part and show you the other segments. It then gets complicated though, and it requires us to know the formula that we learned last week. They say that once my student reaches position Y, remember he will move from X to Y. When he reaches position Y, the platform PQRS is activated and it is going to move vertically upwards by 3 meters. Vertically upwards means your Z value, you add 3. Because we are trying to look at X, Y, Z plane. If you move vertically up, means the Z, you add 3. They call the new position as Y prime after the platform PQRS moves up. So can we maybe just draw in? How does it look like after it moves up? You are thinking of at PQRS, there is a vertical distance now upwards by 3 units to produce this new platform that is here. They are elevating that platform PQRS to go upwards. 3 units upwards in Z's direction. Okay, 3 units in Z. So let's find the equation of the plane after this PQRS is elevated. If you want to find equation of plane, then we need to recall, usually we go for R dot n is A dot n. So we will ask ourselves, do I know the normal vector? Do I know a point on the plane? If you move the plane up by 3 units, this plane, for your new plane, it will still be parallel to the old plane. Parallel planes will have the same normal. So if you elevate by 3 upwards, you add 3. The normals don't change. You should still apply the same normal vector. Parallel vectors or parallel planes will have parallel normal vectors. So I will use back the same normal, which is the 305. But what about a point? Can I have a point on the new plane? The point Y was shifted upwards. They say that the new position is called Y prime. Do I know what is Y prime coordinate? You are shifting the whole plane upwards by 3. If I know the original Y is 42.6, Y prime will be 4 to 3.6. You're only adding 3 with plus 3 to Y coordinate or Y point at the Z coordinate only, because they are moving the whole thing vertically upwards. So I can now try to apply equation of plane. R dot n is A dot n. We use that for the new elevated plane. Equation will be R dot 305 is A dot n, which is another 305 on the right. So this is the equation of the new plane. And last part, G. How do we find distance now between that elevated platform and the original slope? So what are they looking for? This PQRS elevator is a plane. This is also a plane. You need to recall how to do distance between two planes, which is the last part of last week, but I remind you on the formula. To visualize better, let's just try to draw two planes that are parallel so that we can visualize the distance formula. Such that the equation of the elevated one is R dot n is 30. The equation at the bottom one is R dot n is 15. You have two parallel planes. I use this chance to recap on that formula. What is the distance between them? To get distance between two planes is to think about, I go through the whole concept again. What is the distance to origin for each of the plane? If I know the distance to origin of the top plane and distance to origin of the bottom plane, I subtract those two values, it will give me distance between my two planes. We have to think about distance to origin first. How to do distance to origin? I told you just now that you want to look at the formula R dot n cap to be D. This will be distance to origin. You must create the equation of the plane such that there is an n cap. So for my two planes here, my first step will be, can we check what is the length of the normal vector? Because I would like to convert them to n cap. Length of the normal vector is 3 squared plus 0 squared plus 5 squared. I have square root 34. Let's convert both equations to be in a n cap format by dividing both sides with root 34. Right hand side similar, bottom plane similar. So the respective green color line is this value on the right side. If I can convert a plane's equation to this structure of r dot n cap is d, these distances here are referring to these two highlighted in yellow. So we can now finish the problem and try to find distance between two planes given by you take modulus and you subtract those two values. Which we will then get just 15 over root 34 units. The solution looks long only because I was trying to recap on how to draw the diagram and check distance. But once you can remember this, what you should actually do is just to form these two numbers straight away by taking the right-hand side value of the plane, and always remember you divide by mod n. The concept is from the plane equation, divide by mod n for both to reach these two numbers and you can subtract. So I get you to work out, I have a few problems about applications on the next pages.